am Mr. Chairman of this chair, bringing you the most important non-news items of the week.
Gasp!
This week we have 2 cars, starting from one point, going in not one, but 2 different directions.
Ooh, gasp!
Let's cut straight to the footage. Now, kids, do not try that at home. That was very dangerous. Now, here to tell us the rate at which the 2 cars moving away from each other is the casually dressed mathematician, Jeff.
Okay, I'm the casually dressed mathematician, Jeff. So, we can see this situation here. We got one car heading west at a speed of 25 miles an hour to the west, so that is negative. Now, we have another car heading south at 60 miles an hour, so that is also negative. What we don't know is the rate that they're moving away from each other. So we will make that dz over dt. So how do we find dz over dt? Well, we start with this equation, which is from the Pythagorean theorem. And we take the derivative. We divide each side by 2z to get dz over dt by itself. Then we divide by 2 to simplify. Now over here, we can solve for x, y, and z. Starting with x, we know that the rate is negative 25 miles per hour, and they're going for 2 hours. That means the distance is negative 25 miles, or negative 50 miles. Now here we have y. We know that it's 60 miles per hour, negative 60 miles per hour for 2 hours, and that will equal negative 120 miles. Now we can use the Pythagorean theorem again to find z. If we square root both sides, we'll get z equals the square root of x squared plus y squared. Now, we have y squared being 14,400 miles and x squared being 2,500 miles. And that means z has to be 130 miles. Now, we plug what we know into this equation right here. So we have the negative 50 miles for x at negative 25 miles per hour plus the 120 miles for y and at negative 60 miles per hour, all over z, which is 130 miles, and that all equals dz over dt. So we now know the rate the cars were moving away from each other is 65 miles per hour.
Wow, that was interesting. Tune in next week while we count the amount of potatoes in my sock drawer.